An introduction to edge computing. Edge computing refers to a computing architecture that processes and analyzes data closer to the source of data, rather than in a centralized data center or the cloud. This is done to reduce the latency and improve the processing speed of data. In edge computing, the processing is done at the edge of the network, closer to the devices generating the data, such as sensors, cameras, and other IoT devices. Edge computing enables real-time data processing and decision-making, as data does not need to be transferred over long distances to a centralized data center or cloud. This makes edge computing ideal for use cases that require low latency, such as autonomous vehicles, smart cities, and industrial automation. Edge computing also provides benefits in terms of privacy and security, as sensitive data can be processed locally, reducing the risk of data breaches. Edge computing also reduces bandwidth usage as data does not need to be transferred over long distances, reducing the strain on networks and reducing costs. Edge computing has become increasingly important in today's technology landscape due to the growing number of connected devices, the increasing amount of data generated, and the growing demand for real-time data processing. The rise of the Internet of Things, IoT, has led to an exponential increase in the amount of data being generated by devices such as sensors, cameras, and other connected devices. This data needs to be processed and analyzed quickly and efficiently, which is where edge computing comes in. Edge computing allows for data to be processed and analyzed closer to the source of the data, reducing latency and improving the speed of processing. This is especially important for use cases that require real-time data processing, such as autonomous vehicles, smart cities, and industrial automation. Edge computing also provides benefits in terms of privacy and security, as sensitive data can be processed locally, reducing the risk of data breaches. This is becoming increasingly important as privacy concerns become more prominent in today's technology landscape. Additionally, edge computing helps to reduce the strain on networks and reduces costs by reducing the amount of data that needs to be transferred over long distances to centralized data centers or the cloud. This makes edge computing an important technology for companies looking to optimize their data processing and reduce costs. Edge computing and traditional cloud computing are both methods of processing and analyzing data, but there are some key differences between the two. Location: in traditional cloud computing, data is processed and analyzed in centralized data centers or the cloud. In contrast, in edge computing, data is processed and analyzed closer to the source of the data, at the edge of the network. Latency: one of the main benefits of edge computing is reduced latency, as data does not need to be transferred over long distances to a centralized data center or cloud. Traditional cloud computing often results in higher latency, as data must be transferred to a centralized location for processing. Data volume: edge computing is designed to handle smaller amounts of data, generated by devices such as sensors, cameras, and other Internet of Things, IoT, devices. In contrast, traditional cloud computing is designed to handle large amounts of data generated by multiple devices and sources. Cost: edge computing can help to reduce costs by reducing the amount of data that needs to be transferred over long distances to centralized data centers or the cloud. Traditional cloud computing often involves higher costs due to the need for data transfer and storage in centralized locations. Privacy and security: edge computing allows for sensitive data to be processed locally, reducing the risk of data breaches. Traditional cloud computing can result in increased privacy and security risks, as sensitive data must be transferred over long distances to centralized data centers or the cloud. In conclusion, edge computing is a revolutionary approach to computing that brings data processing closer to the source of the data. This results in faster response times, reduced bandwidth requirements, and improved reliability. Edge computing also opens up new possibilities for real-time data processing and applications, making it a critical technology for organizations looking to stay competitive and innovative. With the rapid growth of the Internet of Things and the increasing demand for real-time data processing, edge computing is set to play an even more important role in the future of computing.